So on the 26th of April, we finish our final session. We're going to call this networking wrap up. We're going to talk a little more about the DNS solution, your second solution for this module. You have two solutions, one involving routing and the other one involving the DNS solution. It's a very quick and simple activity, but hopefully very gratifying. Today, we're going to review how you create UDP and TCP connections using coding methods. This is the part of our course that we need to loop back to your given major. If you're a computer science major, it's all about writing code. And now that you have some context to frame the discussion of how to establish TCP and UDP connections, we'll be reviewing a couple of quick methods, and one I love to use in Python for hacking purposes. We'll also be talking about security basics. So at the end of this class, the CSC 243 student will be able to describe the steps to complete the DNS solution, provide specifics for network coding essentials, and specify simple requirements for effective network security. Yeah, if you can't lock down your network, it's great to be able to code things, but it's also important to be able to secure your network. Any questions before we jump in?
No questions.
Okay, so let's talk about DNS. So I've created a DNS server, and essentially, let's pull up your Blackboard assignment. So in Blackboard, the second solution, you have until 1 May to finish this one. I'm going to be extending the deadline for this one. I thought I already did. Let's just make sure we did that for the routing solution. Yeah, you had until tomorrow, 11:59 p.m. to finish the routing solution. Don't worry about the header and what it says. We'll modify that in a minute. You have through the end of this week until 1 May. That's Saturday. So you have until this Saturday. If you need longer, you can take longer to complete the DNS solution. But essentially what you're going to do is email me your custom domain name. Now, I've created a couple of custom domain names, one called snurkle.com, the other one called my custom domain or my creative domain. We'll show you that in a minute. But you email that to me, and you want to include in your email the subject line, my custom domain for implementation. You get a point for doing that. I'll send you a link to set the day and time to share a screen to build out the DNS zone interactively. And here's what we're going to do to build out your zone. I'm going to open up my server, my DNS server. And I'm going to, here's when I created my own creation.net, right? And basically you need to come up with a DNS name that isn't common out there, that's something creative that doesn't previously exist. So, please don't submit something like abc.com or hbomax.com or something like that, right? Somebody told us to create a domain called midnight.net, and it's actually out there, it's already existing, and so that's not a good fit. But You come up with something simple. The best way to determine whether or not your custom domain is unique is to simply try to browse to it. So if I say my creative.net, one of two things will happen. It'll redirect to some other website. And so this happens to be Korean. I'm pretty sure that's Korean. In general, if it redirects to another domain, it's probably owned by somebody else. But normally you'd get a splash page for how to register your domain. So let's take, who would like to volunteer their first name and last name as a domain name? I need a volunteer.
I don't volunteer.
Oh, sorry.
Okay. Ladies first. Deanna Hunt.biz. Okay, it's going to say that it can't be reached. That's a pretty good sign that that it hasn't been taken. Or if you get a site where you can register a domain, if something like this pops up, if all of a sudden you're redirected to a place where you can anchor your domain or register your domain, depending on your service provider, your internet service provider may have those types of things pre-configured. And so it may not redirect to this specific web hosting provider where you can register domains, but you can register domains and establish your own certificates for encrypted connections and all that coolness, right? So that's another good sign that you have a unique name. I'm going to do the same when I receive your name. I just want you to understand. And assuming that you have a good name, I'm going to share the screen with you and you're going to see something like this. And I'm going to create a new zone, a new primary zone. This is the lead set of records for this new domain on the primary DNS server. And I'm going to give it the name DeannaHunt.com, or was that .biz? .biz. Okay. And I'm going to create that domain name. And then I'm going to go inside that domain name and I'm going to create a host record for a fictional website that Deanna has already set up. The name of that website is Virgo. And the Virgo web server is her web server. So I'm going to put in the address for that website. I'm going to add a host. And I'm done now. And then I'm going to create what's called a CNAME or an alias, which I call www. I'll browse to Deanna's new website on Virgo. And then in true systems engineering technology professional fashion, because I've added new information to my DNS server, I want to clear the cache in case anybody else has previously searched for DeannaHunt.biz and got a negative result. And you saw that happen. I got a negative result and it said, hey, the website isn't found. And that's going to stick in the cache here. So when I try to use this DNS server again, if I don't clear that, it's going to come back to haunt me. Does everybody understand what I just said?
Yes.
Okay. And then I'm going to restart the service. So I clear the cache and I restart the service. Then I'm also going to do this on my machine. I'm going to type in this command, ipconfig flush DNS. because I want my local cache on my system. So this was the server cache that returned the negative result. I also got a negative result on my web browser. So on the local DNS cache on my laptop, I have to clear that. Now the trick is to test to see if this named resource can be touched or talked to. So I'm going to ping, let's see. Let's ping the server first, virgo.dianahunt.biz. Aha, we got a positive result. That's a good sign. The next thing I'm going to do is open up a web browser. And I'm going to go to www.dianahunt.biz. Aha! And Deanna's web server splashes on the screen. Deanna's going to take a screenshot of this. Deanna's going to take a screenshot of this, where I have flushed the DNS and then tested with a ping. So for your criteria, right, you're going to show up for the joint session where we share a screen. That's the second point. You're going to get a screenshot of the DNS zone that's set up on my server, right? And oh, the other thing too is you're going to do this from your machine. So yeah, you can get screenshots of my machine hitting that address, but ultimately what we want to do is we want to show you how this really works universally. DNS is that international global language. So what we're going to want you to do for just a second is to go on to your IP configuration. And for just a second, we're going to want you to do this with your machine from your home. You're going to enter the IP address I give you for my DNS server. And for just a moment, you're going to use my DNS server instead of your internet service provider's DNS server. Now, why is that? You haven't officially registered or paid to register your custom domain. You don't technically own it internationally, but for the purpose of creative license and demonstrating the method academically, we're going to create what you have to do to set it up. And then you're going to point your machine at my DNS server. You'll do the IP config /flush DNS. Then you'll do a ping. Hopefully you'll get a result. If you don't, you can simply use my own screenshot to validate that the thing is working. Sometimes weirdness happens with your own wireless Wi-Fi router. We're not going to try to troubleshoot networking connectivity issues, but one way or the other, we're going to get a positive result here. That's part of the criteria you submit. Then you're going to show the successful ping to the server. So those two things together, a screenshot of the configuration that you've set up your DNS, my DNS server on your system, a successful ping to the DNS server, and then a snapshot of the website splash screen showing the custom domain and the URL. So I'm going to see this highlighted at the top, and that's going to be your custom domain. Any questions about what we're doing for your final solution?
No questions.
No question.
Now, if you love your domain name and you'd like to make it global and international, you can go to 1&1 or Ionos or Rackspace or GoDaddy. There's a number of places. You can register a domain name for as little as $1 a year. And then when you have a resume, you apply to grad school, you want to get hired by the VI government for networking, you put your domain with your links on your resume, and they click and they see your web service. They see your web server running. There's nothing cooler than that. That proves that you know what you're doing with your networking, right? Seeing is believing. Show them you know how to set up facebook.com. Yeah. Any questions?
No questions.
No question.
All right. So next we're going to talk about showing the world how you know what you're doing with networking, because you know how to code solutions that build in connectivity across the network with your coding statements, right? Now, one of the first things you have to negotiate here, and this goes without saying, but I'm going to take just a moment to say it. A lot of times you can work a solution with coding software and you want to use a specific port. Perhaps you have a database application, you're using MySQL, and you want to use the SQL ports, 1434 and 1433, I think, those two ports. And you work up the stuff to do it, and it doesn't work. One of the things you need to do when you're coding is make room on your firewall. We're going to be talking more about firewalls in the last portion of our class, but basically everybody thinks network security is all about having a decent firewall, and that's only a part of the solution. Having firewalls is kind of like having antivirus. You can have antivirus software, but if it isn't up to date as a trial version, or a lot of extra rules are in there, depending, I mean, you get what you pay for. It's only part of what keeps us safe on the network. A firewall is only a piece of that, right? But it is a major headache if you don't plan ahead to enable a specific TCP or UDP port as you're coding. If you don't do this first, then when you go ahead and try to run your statements, it'll never work. And you're like, Kentop lied. He lied. These statements in C++, these statements in Java, these statements in Python, they all look so simple, but they're not working. Why aren't they working? I told you first, you have to go ahead with your firewall. I'm going to go and show you exactly what to do to set up your firewall. If I go into Control Panel, and I open up Windows Defender Firewall, you can do this with a Mac, by the way, too. I'm going to go to Advanced Settings. And what I want to do is define some inbound rules. So remember that when you're forming a connection on certain hosts, when you're using a target host to run that software, that host has to have a port that is going to be accessible for that connection. The firewall on that target system is not going to be open. So on that target system, you're going to create a test rule, and it should be listed alphabetically. Oh, come on. And test 1 and test 2. Well, there it is. There it is. Okay. So all I did to set up a new rule was to click inbound rules. Now you're doing this, once again, you're doing this on the system that you're using to test your coding statements against. What am I saying? You're going to have two systems that are running, the one you're coding the statements with and the one you're trying to make a connection with on the other side. And it's this other system you have to adjust the firewall rules for, okay? So you remember, you always have two sides of that connection, right? So I'm pretending that my Windows machine is the target machine I'm using for coding purposes, right? This is called test-driven development. So I'm testing my connections with each statement. I'm testing the output for each statement. I'm validating the inputs for each statement. I'm doing safe coding practices. That's something we go into in some cyber courses. But in any case, I've got this firewall statement if you create a new rule, it's best to create a custom rule and then specify just all programs, because you haven't developed your software yet. You don't know what the name of your executable is going to be. It may change 100 times before you're finished. You're going to specify TCP first, and then you're going to specify a specific port. Let's say I'm using SQL. I'm going to go ahead and say 1434. I'm not going to specify what the remote port is or what the client side port has to be. It's acceptable from any IP address, right? I'm going to allow the connection. These are firewall profiles. I want all of those checked. Then I'm going to give it a name, like test database SQL rule 1, right? Something like that, just so I know what it is. And now I have test database SQL rule 1, and it's on port, it's enabled port 1434 TCP. So now when I try to do my coding statements, I'm not scratching my head going, what did I do wrong with my coding? Does everybody follow what I've just explained?
No, so we're gonna be adjusting firewall temporarily, right?
Yes. I'm adjusting the firewall temporarily. Now, after you're finished coding your solution, if you have a specific custom port you have designated for your software to work, you're going to give instructions for your software installation, right, to modify the local firewall to allow port such and such. If you connect to a website that's encrypted, right? If you have an encrypted website, you'll see a padlock instead of something that says not secure like this, right? This is a port 80 unencrypted website connection. It's not secure. It's not a best practice. It's considered a best practice to encrypt your website connections with the clients using TLS to provide an HTTPS connection. Every now and then I say SSL. SSL, Secure Sockets Layer, has been retired or deprecated. TLS is the new way to create a padlock for HTTPS. In any case, it's on port 443. So you know as well as I do, sometimes you'll get software installation setups and it'll say, hey, you have to modify your firewall in order for this software to work correctly. Do you want us to make that change for you? You can include code in your application to create the firewalls for your users. That's what happens when you install most software. Most software includes additional code to open up ports, so the users don't even think about which ports to open. If you're doing it for an enterprise, Fortune 500 company or a government agency, you're going to want to specify which port numbers, and you're going to want to coordinate with the IT department to make sure that those aren't just automatically defined. If you have a large application like Angry Birds and it's network enabled and you want to be a billionaire by the time you're 25, right? The guy who created Angry Birds was an overnight millionaire. And if he had that app for everybody to load and there were a network component to it, I'm just saying he or she would have included the network firewall rules. And that's why you see so many applications listed here. So your code can install a firewall rule based on an application, and it'll allow traffic based on the application, not on a specific port. That's another way to work around it. Any questions on firewall issues? Be sure to read all of this. Okay. There we go. 1433, 1444. There's some links there. Okay. The socket API. Application programming interface. Socket API is a standard coding method that most computer science students are very, they're either they're very well familiar with it, or they've been tortured by it. Sooner or later, I think a little bit of both happens. Comer provides a lot of great reference materials, and Comer essentially works with C++. And the methods for, or actually the function calls, are a little different based on the programming language, but conceptually, what you're doing in each case is similar. Let me say that again. The function calls differ based on the language, but what you're actually doing in terms of tasks is universal. So I want you to understand this. These first three steps have to happen on the server side. There's a socket that's formed and it's bound, right? You bind to the socket, and now that service is listening on a port. It's listening for a connection from the client. On the client side, a socket is formed, and then there's a connection. The server accepts the connection. There's send, receive, send, receive, send, receive, send, receive, right? All that ACK, send ACK, ACK, three-way handshake business. Here's the most important part. The uninitiated and novice coders forget to close the connection. This is very bad, very dangerous. And if you want to become the poster child for what not to do when you code solutions, just leave your network connection open in perpetuity. Leave it open forever. And eventually somebody's going to like really give you a hard time about that. I mean, a very hard time about it. Any questions about the diagram I just showed you? Any questions about this diagram, about the tasks and the little dance that happens on both sides?
No question.
Okay, so here's the part I want you to understand, and this is the most important part. For your software to work, are you coding for what just happens on the client side? Or are you also coding statements for what happens on the server side? Hello?
Both?
Both, yes. I'm calling that out intentionally so that you understand this. It's really easy for people to start coding stuff and they're like, okay, I did the statements, I followed the example, and I'm like, okay, did you do both sides? Because first you have to set the stage on the server side. Now it's listening. Then you have to have these procedures and statements that fire off on the client side. And there has to be this hand in glove, hand in glove, hand in glove, hand in glove kind of thing that goes back and forth between the client and the server. So one of the challenges for understanding network software solutions is just getting the fact that it's a two-way street and it's interactive. But if you get that down, if you understand this much, oh my gosh, you'd be shocked at how many software engineers just don't really do a good job of that. They don't understand that. If you spend the time becoming one with this socket API and understanding this two-way interaction, that's where the big money is. You have companies like Apple and Cisco and Microsoft that are coding network applications all the time. And you bet your bottom dollar when they interview you, they're going to be asking you questions about the socket API. It's actually conceptually a very simple process. So even though this diagram looks like a lot of business here, and these bullet points and steps, there's a lot of detail there, right? The main thing is you're creating a socket. You're using the functions to configure it. Once it's configured, you use it to send and receive data. And then remember the last step, unless you want to be the poster child for how not to screw up a network application and leave everybody exposed and vulnerable, and then the world hacks them. And then you're like the cybersecurity poster child for how not to screw up everybody's network, right? So please don't forget that last one. I ought to make this in bold. In fact, I'm going to do that. I think I'm going to do it that much. Oh yeah, there's a revision 2A that I'm working on here. I've just changed a couple of details at the end of this study guide. So I do have an update for the study guide. This is on slide 121 in Comer. All right, so here's how the detail works in Java. There's an online link, right? So, you know, here's the thing. Comer has great examples. And what sucks about Comer's examples is that they are not in Java. So I provided some for you, okay? Anyway, you're going to click on this link to go to the Java examples. There are 3 important classes when we're talking about Java: server socket, socket, and INET address. On the server side of the connection, well, that makes sense, doesn't it? Server socket is really for the server side of the connection. Makes sense. What are we talking about? The server side, this side of the connection, right? Are we good? Any questions at this point? In Java, you have server socket, INET address, and socket. If I ask you which programming language includes server socket, socket, and INET address, are you going to select C++ or Python?
No.
No. You're going to select Java, right? All right. So, can everybody see my screen?
Yeah.
Yes.
Yes.
Okay. So do I want you to click this link so you can get more information? Absolutely. What's the most important point I want you to know? Well, these 3 classes. So which side handles the client side of the connection? If server socket handles the server side of the connection, would you care to guess which class handles the client side of the connection?
The socket.
Yes, give the man a cigar. Outstanding. Okay, socket. Yeah, that's true. So, yep, that's an example of what we're doing on the server side of things. On the client side, right? Socket. This part right here. I'm going to come back to that over and over and over again. What don't you forget at the very end? Close. Please close. Because that's what causes all sorts of hacks to happen. And then updates, it's like, oh my gosh, the code didn't close the socket. Oh my gosh, we have to update the software. Nobody's loading the updates. Oh, we have to bundle it into a critical operating system patch now. Oh my gosh, you really don't want to become the poster child, right? Okay, C++. And in C, kind of a similar set of steps. The function calls are a little different, but sock address. So data structures set the stage using sock ADDR and sock ADDR in. Sockets are set up with socket bind and get sock name. Okay. So a very similar process. We're setting the stage. We're creating the sockets. Then we're connecting with the sockets. Connect, listen, accept, get peer name, all that kind of stuff. This is all very logical once you understand how a socket and an online connection is framed. How, you know, how's the stage set. Socket communications are controlled with, then you use that connection to send and receive data, send to rec v, rec from, and what's the most important function of all? Close. There are also host server functions useful in working communications, get host name, get host by name, get host by address, get server by name, get server by port. So yeah, there you have it. All right. So you've had a taste of what's going on with Java and with C++. Distinctly different flavor there. Shouldn't be hard to distinguish. Those are the essentials, right? What about Python? Well, if you've heard of something called Kali, Kali has a flavor of Python that's great for hacking. And there's a book called Black Hat Python. It's a very inexpensive book. It's available on Amazon as a Kindle book. Basically, if you're using Python, see, and this is when you consider that Python is active on most Linux distributions. Most Linux distributions have Python preloaded. So if you're running Linux, you're good to go. You can take off right away with this, straight away with this. That's why hackers love Linux. Has anyone ever heard of Kali or Black Hat Python?
Yes, I've heard of Kali.
Same here.
Okay. So let's look at what it takes. Now, I have two examples, one for a TCP socket and one for a UDP socket. Okay. And basically the main steps are described. So the little black circles here, step one, we're going to create a socket object, right? So one thing I like about this author is that he's providing examples where there's a little more of a descriptive variable name. At least you know what the heck you're dealing with here. So client is the, variable name. There's enough information so you can follow along. Here he explains, we first create a socket object with AF inet and sock stream parameters, right? So import socket is the first command, target host and target port. So this gets really interesting as long as you know the name or the IP address and you know what port you want to deal with, you can create a socket on a port, right? And so you create that socket, then you connect the client, then you send and receive data. Notice the pattern. This is a thing of beauty. It's so complicated in most references, needlessly so. What's step one? This is like a waltz. This is a beautiful thing. People freak out when you get to the coding part. I don't know why. What are we doing? We're creating a socket. Then we're connecting the client with the socket. And then we're sending and receiving data. 1, 2, 3, right? That's a waltz. And then you get some response back from the client. What's the last thing you should do? What's the last thing we should do?
Print the response.
Well, that's what it says. It says print response. So you know what got transferred. What does this not show you?
Close it, close the socket.
Oh, yes. Horror of horrors. I'm going to print something very obvious here. Let's make it a little more interesting. What did he forget? Close, close, close. But think about it. Think about it. That's what hackers do. They get in, they get into it, they start getting and sending and receiving data, then they lose their heads. They're so giddy with excitement. They're like, I finally cracked into this and I'm using custom code to do this. Dude, look at my screen. And then they leave something open, which is why we like using this command. Have we not introduced you to this command yet? Have you seen this command yet?
I've seen it, I think, but I'm not sure if you used it in this class.
Yes, you did.
You did, right?
You absolutely did in the very first module.
Okay, yeah, I'm sure.
And so that we've come full circle. Net SH, net stat, GRC shields up. And the very first module, at the end of that study guide, we talked about some simple things that you do to identify some goofy stuff, right? If you have netstat-a, what does that do? Well, it catches junk like this going on where somebody's hacking and they've pried open a connection on your system, and there it sits open or listening or waiting, right? In fact, here's what I'm going to do. I'm going to redirect the output of this command to a temp file. And I'm going to call this port status .txt, right? So I'm going to hit my enter key again, just because netstat is a little stubborn. For some reason, netsh doesn't do this, but what it's going to do is give me a prompt back in just a second. I'm going to wait for it here to show up on my temp folder. Port status. I've got something there. Is it finished writing? Not quite. So I've got a partial file. It isn't finished writing yet. It takes a while to run, but essentially that's what you're doing. You're running a simple command because you want to see if there's something that's listening or open. Any questions?
No questions.
Okay. What's essential for security? Safe coding practices, which absolutely end with closing the port, right? For a UDP socket, same thing. Create the socket, send and receive data. Oh, hey, we're not formally establishing a constant connection. We're just creating a socket, then we're sending and receiving data. Oh, wow. That's a direct flight, isn't it? See if it's even easier. And yes, there's the last statement the author gave us, print data. What did he forget again for a UDP connection this time? Close.
Close the socket.
Yeah, close the socket, right? So he created a socket, then he send and receive data, right? Send and receive data. We're going to print it so we can see it. And then what? Close, please. Don't leave the door open. There are other basics that I want you to be aware of. Did we or did we not talk about managed networks? We have basically 60 seconds to finish hitting a most important thing. Everybody remember DHCP?
Yes.
Yeah.
Simple requirements for effective security. Well, code that closes a connection. That's number one. What's number two? A managed network, starting with the purchase of a managed switch. I'm going to put some extra credit assignments out there. These are optional. There will be 2 optional assignments. The first one will allow you to use these methods in Python to connect to something. I'll have a video. You can do it during exam week if you have time. If you don't have time, that's cool. You don't have to do it. I'm just going to put it out there. The other thing I'm going to do is give you an opportunity to take a look at a simple video. I'm going to post a video at the end of the latest and final version of the study guide, right? So what I have here, I'm going to post a link for you to get into a video. And essentially what I do is walk through, and I'm hammering this in a lot of classes right now. So if you have an effective network, it starts with a managed switch. A managed switch allows you to specify your DHCP helper. So an unmanaged switch, everybody goes cheap, and they don't spend any money on switches. I have a short video, and I've actually got a diagram that I drew in one other class. But in simple terms, if you have a managed switch, you can specify where as your clients connect, you can basically drive them to connect to a DHCP server. Once you have them connected to a DHCP server, you can automatically assign where they're getting their DNS from. You can lock that down. You can automatically turn off NetBIOS. Here's what I mean. Okay. Where are we? Can everybody see my screen?
Yes.
Okay. So the average Wi-Fi router doesn't include additional measures, but for very little, extremely little outlay of cash, you can build out your own scope, and you can have specific policies, right? And you can also define server options. For example, you can set where your machines sync the time. Believe it or not, there are attacks and exploits called replay attacks. But if everybody's getting the same time signals from the same time servers, you can't do that. Where you get your DNS servers from, where your network information is logged, right? Let's see what else. There was some really cool stuff in here. Broadcast addresses. You can specify different broadcasts. There's a simple static route option. You can define a static route so that when people connect with the DHCP, it loads a static route so that you can define where the network traffic goes. You can specify the TCP/IP NetBIOS over TCP/IP thing we were just talking about. All of that. You can lock down everything. And the simple truth is, people just don't realize that we're talking about a simple difference. When you go to Office Max, Office Depot, and you buy, let's see, where are we here? Okay, so, oh, this is a good one right here. When you go to Office Max, what often happens is that people buy the cheap stuff. They buy a quick unmanaged hub. Everybody likes to buy unmanaged switches. Your job as a technology professional is to say, no, no, no. you want to spend a couple of $100 more, you want to get this kind of switch. When you get this kind of switch, you get to have VLANs. You get to have VLANs. You get to uplink other switches so that you have this backbone. You get to bind the ports together. It's called port aggregation, so that you can have 4 by 1 gig coming out of a server to update Microsoft updates locally 1,000 times faster on your local network than you do over the internet. You have quality of service issues where you can define more traffic bandwidth for voice connections, for voice over IP phone connections versus other types of connections. But the most important thing is that you can drive all of the connections to a specific DHCP server. It is most important that you understand that by defining the scope options, including DNS, then you can lock down everything else for those connected devices. That means that they're anchored to a domain, which is a centralized managed account database for security reasons. It's very important. It's an anchor. You spend $300, okay? Spend $300 instead of $50. And what you get is a world of difference. But you're going to get people you work for that are going to tell you they don't need a managed switch. They can just buy an unmanaged switch for $50. And so what are the essentials for effective network security? Well, you want DHCP and DNS services of your own. You want to lock those down. But you also want everything that connects to be connected in a specific fashion, in a specific manner. So you have control, so that you have security, so that you have good bandwidth when you need it. The only way to do that is to have a managed switch. And that's the anchor point. If you don't buy a $300 managed switch, anybody you work for that says they can't do that is penny wise and pound foolish. I want you to have them call me. I will buy them lunch. I will explain this to them if they don't believe you. Is that a deal? Do we have an
Yeah.
accord? When you go out into the professional workplace, don't let somebody, you go to all this trouble to set up a nice software, network-based software application. You go to all the trouble to do these things, to create segmented networks, to have better security. And they go out and they buy a stupid unmanaged switch for $50 because they think they're saving something. Don't let them. Tell them. Truth will set you free. Okay? So, any questions about effective network security and where it begins? The answer on your assessment, your retake, and your final exam should be a low-cost managed switch that defines, with an IP helper statement, where everybody gets their DHCP attributes and network assignment from, right? You define all those things, you lock all those things, and then everybody's not flying around, flapping around, open-ended, all exposed, willy-nilly, every man for himself, every woman for herself. It's a horror show. You have a professional workplace environment instead of a private home network that's really good for sharing streaming media. And it's like two different worlds, okay? Before we close, are there any questions? Going once. Going twice.